This is the rotifer colotheca. If you were to ask me how big is it, how should I respond? When we share videos and photos from our microscopes, it's important that we accurately describe how big these things are. Today, I'm going to share with you my method for creating scale bars that I add to my photos and videos. Why do we need scale bars? Why can't we just say, I used a 10x objective, I used a 40x objective? Doesn't that give enough information to determine the size of what we're looking at? Let's say we're taking a picture of a microscopic organism. You can see this organism between the two monitors as a small little dot. When we share our video with other people, depending on the screen they're using, the organism may look larger or smaller. Even though both of these screens are showing the organism taken with the same 10x objective, we can't say that the organism is 10 times its actual size. As you can see, the large screen TV displays the organism much larger than the computer screen. And if we were viewing on a cell phone, the organism would look a lot smaller. Compared to its actual size, we know nothing about how big it really is. By embedding a scale bar in our image, we will always have an accurate representation of the size of the organism. In order to create our scale bars, we need an accurate method for measuring our field of view. To do this, we use a calibration slide, also known as a micrometer. Calibration slides are not expensive. I think I ordered mine online for about $5. The calibration slide will have various scales etched into the glass. Find one of the scales that completely covers the field of view of whichever objective you're using to look at the slide. Here, I've aligned the large hash mark at the 7 millimeter mark with the very left edge of my field of view. And now we can see that my field of view extends for 1.4 plus a tiny little bit millimeters. Now that I know this measurement, I have enough information to do some simple math to calculate the size of my scale bars. Before we build our scale bar, we need to do a little bit of math. Let's take a look at what we know already. We know that we're using a 10x objective. We know that the camera resolution is 1920 by 1080. And we measured with the micrometer slide our field of view width, 1.41 millimeters. So how do we calculate the field of view height? We do a little bit of simple math, cross multiplication. First, we write down 1.41 millimeters is to 1,920 pixels as x, the number of millimeters of the height of the field of view, is to 1080. We cross multiply and we end up solving for x, 0.79 millimeters. Now that we have that information, we can calculate how many pixels across our screen we would need to accurately create our scale bar. We do this by another cross multiplication. We know that 1.41 millimeters equals 1,920 pixels across our screen. So let's say we wanted to have a 400 micron or a 0.4 millimeter scale bar. How many pixels across the screen would it take for 400 microns? Cross multiplication reveals that would take 544 pixels. I use Adobe Photoshop, but you should be able to do the same thing in any image editor that you have. The first thing I do in Photoshop is to turn on the rulers. It's critical that we're able to measure the number of pixels across the screen as we draw our scale bar. To show the rulers, under the View menu, we select Rulers. When you click on a ruler and drag onto your canvas, you can place a guide on the screen. And as you can see, there's a little indicator of the X value as I move left and right. If you remember, I want 136 pixels, and that will represent 100 microns on my scale bar. In order to see this more easily, I'm going to temporarily turn on a gray background. And now you can see that I've placed 4 guides, each 136 pixels apart, representing a total of 400 microns. The next step is to use your drawing tools to create the scale bar. I'm not going to go into detail on how to use the line tool and the text tool to draw the scale bar. It's time to export it. But remember, we need to turn off that background because we want the scale bar to be transparent when we overlay it in our photo or video. We use the export function to export as a transparent ping and save it to the hard drive. Now that we've saved our scale bar to the hard drive, we can import it into DaVinci Resolve or your image editing program to add it to your image or video. You'll notice that I've created both white and black versions of my scale bars. That way, I'm able to see it whether it's on bright field or dark field images or videos. To bring it into DaVinci Resolve, I just drag it into the media pool. And from there, I place it on the timeline in the track above my video. Now I have a scale bar that I can extend or shorten for whatever duration I want it to be on screen. I can use the white handles at the top of the scale bar's track to fade out and fade in. I'm stretching it across the entire clip, and now all I have to do is play the video with the scale bar in place. If anyone asks me how big the rotifer is, I can confidently describe the size of the rotifer, its egg, and its poop. Let me know in the comments if you have any questions about this process. I encourage all of you to make scale bars and add them to your microscopy videos and photos.